Okay, so today we're doing the hands-on lab for waves. And I already have everything set up, so we're just going to get to it. So the procedure, place 5 or 6 marbles in a groove so that they touch each other. I'm just going to use these two because I didn't have a grooved ruler. The vibration of the waves must be transmitted. Okay. So they all move. Yes, they
Except
definitely
for one.
Well, I mean, there's going to be experimental error, Grace. Okay. So now I'm going to do 2. They all move that time. Come back.
There's none left in.
Huh?
Nothing.
All right. Then. So now I'm going to do 3. They all just move after. Okay. Observe and record your observations. So the energy goes through all the marbles and they all eventually move. Kind of like Newton balls. Sort of. Not entirely the same though. Okay, number 2, move the hose or rope up and down to make transverse waves. All right, Grace. Okay, so here are the waves. And I have to draw them, so I've already done that. The wave goes through the rope, so this is the wave motion. And the energy is also going that way. And obviously there was more than just one wave, but I thought it was a little easier to see this way, so technically it'd be like this. Alright, next one. Fill a pan with water, place on the tabletop. Medicine dropper. Okay. Oh, sorry, that's in the way. Oh, okay.
Nice.
I gotta put these down. Okay, I'm gonna let it chill for a sec. Okay. That's so cool. You can see the light shining down. You can see where the waves go. Okay. So it starts in the middle and then it disperses out, and as soon as it hits the outside of the pan, it comes back in and in and out and in and out. And so I drew that here. Here's the pan, and these rings right here, they are the waves. And so first it goes out, 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 and then it hits the outside and goes in. And that's the first part. Now the second part, on the side, it goes here, and the wave goes all the way to the other side of the bowl, and then it hits each other and then goes back. Okay, and here I drew that. This is the point where the drop was put in, and then it go out, and it hit the other side, and then it go back to where it started. Okay, next one. I'll use the same pan or water from number 3 and drop a small stone in it. Okay. It was the same as the first one. So, yeah, it's basically the same as the first trial with the dropper. The waves would start where it was dropped, they'd go out, and then it'd come back in. Okay, and then the same procedure with a penny. And make sure to drop the penny flat in the water. I'm gonna take that out. Okay. It was the same again. The shadows were exactly the same as the first dropper. The first trial of doing the dropper. Yep. Same. I feel like we did that wrong, but I don't know what to say. It's exactly the same. All right. So the analysis now.
It didn't go like straight down, kind of to the side of it.
Well, yeah, that was just kind of because it hit it. Yeah. What are you gonna do? Okay, so the analysis. For each of the procedures above, name the type of wave created and draw a diagram labeling all the important features. Okay, so this one, the marbles were, what is it? A longitudinal wave. And so they were compressions and, oh shoot, I forget the other word. Dad, it's compressions and what?
Rarefactions.
Yeah, rarefactions. And the next one was the rope. The rope was a transverse wave. And what was the next one after that? Oh, the water. All the water ones were also transverse. Wait. No, that doesn't sound right. Yeah, no, these were also longitudinal waves because the compression was the wave that we saw move out and back in. Okay, yeah. And this, here, I guess I should label these. Longitudinal waves and transverse waves. And for here, I labeled all the parts of a transverse wave. So all these are the crests, all these are the troughs, and then right here is the amplitudes of each one. And what else? The wave motion is that way, and the energy is also going that way as well. And for longitudinal waves, these right here where the waves are close together, these are compressions. And then where they're not close together are the rarefactions. Okay. What else? Oh, reflections and refractions. So a reflection is the wave hitting a barrier and going the, how do I say that? Opposite. Hitting it and going the opposite direction that it hit. And here is the line of the perpendicular line to show how it's going the opposite angle as it was the first time. And refraction I showed with water and a pencil like they did in the video. And it kind of distorts the way it looks because the light waves are going through a new medium, which is the water. What else? Oh, number 2 for analysis. What are the properties that a medium must possess in order that the waves may be transmitted through it? Well, it has to be matter. So like it couldn't go through space. It has to be, like a solid, liquid, or gas. And the last one, what is the essential difference between a longitudinal wave and a transverse wave? So longitudinal waves go parallel with the medium it's going through, but transverse waves go perpendicular to the medium it's going through, which I wrote here and here. And I believe that's it. All right. Thank you.